The quadratic formula is used to factor quadratic equations. Now, it is very important to memorize this formula because you're going to be using it for a while. So the formula is for equations that look in this form. Where A, B, and C are going to be numbers. So I want to put A, B, and C are going to be elements of real numbers. So it can be any number. It's ideal when they're all integers. So now this is what we're going to do. The equation is negative b plus or minus the square root of b squared minus 4ac, and everything is going to be divided by 2a. Now, whenever you're dealing with a quadratic formula, you have the plus or minus. This actually means that you're going to be dealing with negative b minus b squared minus 4ac all over 2a. And then you're also going to be dealing with another case that's going to be negative b plus the square root of b squared minus 4ac all over 2a. Now, instead of memorizing this one and this one, we use negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, this formula is going to be stuck with you for Algebra 1, Algebra 2. You're going to need it for geometry. You're going to need it for trig, for pre-calc, for calculus, and when you get to college, you also use this formula. It makes things a lot easier. Let's go over some examples. Let's say you have the equation x squared minus 2x minus 3. So the first thing that we need to do is identify your a, b, and c. So we have a is always going to be the number that it's in front of the x squared. In this case, it's going to be 1. B is going to be negative 2. And c is going to be negative 3. So we're going to write our formula. So that's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to be using our numbers. We're going to plug them in. So we're going to start with negative 2 plus or minus negative 2 squared minus 4 times 1 times negative 3. And then you're going to divide that by 2 times 1. Okay, so we're going to simplify as much as we can. So at the beginning you have negative and negative 2. That's going to be positive 2. And then inside you're going to get negative 2 times negative 2 is going to give you 4 minus 4 times 1 times negative 3 is going to give you positive 12 all over 2. We're going to simplify this a little bit more, and that's going to give you 2 plus the square root, it's 2 plus or minus the square root of 16 all over 2. And that's going to simplify into 2 plus or minus 4 over 2. Now I'm going to split it into two cases. The first one is going to be with a positive, so 2 plus 4 over 2, and that's going to be 6 over 2, which is going to be equal to 3. And the next one is going to be 2 minus 4 all over 2, and this is going to be equal to negative 1. So the two roots that you're looking for is x is equal to negative 1 and 3, and that will be your answer. For example number 2, I'm not going to do it all, I'm just going to help you set it up. So let's say I give you the problem 5x squared is equal to 80. Now this doesn't look like a quadratic equation, so I need to move the 80 to the other side. So I want to rewrite this as 5x squared minus 80 is equal to 0. In this case, we're only going to have an a that is going to be equal to 5. We have a b that is equal to 0. And then we have a c that is equal to negative 80. And now you can plug it into the equation. So for example 3, you already have a problem that I already worked out. Now, there's something specific that I need you to look at. Right here, inside the square root, you're going to get that your b is too small compared to the negative 4ac. So, when you simplify this one more step, you're going to get the square root of negative 47. Now, since we don't deal with complex numbers or imaginary numbers, you wouldn't continue solving this. This will be your n, because if you continue, you will get a negative number, and that's going to get, you will get an imaginary number, and that will get a little messy. So if you ever get into a point where you have something like this, you know that there's no real solution, and that's why we're going to write no real solution.